Hello guys, welcome to Tariq's class. First of all, I am very proud of you. Do you know why? Because you have the courage to retake SHSAT. You are a warrior and I am here to help you. So today I'm going to discuss 5 most important SHSAT questions for the 9th grade SHSAT. These questions are almost guaranteed to come on the test. So please give your full attention. So number 5. So Raul has 2 containers. One is a cylinder, okay, with an inner radius of 4 inches. So let's draw a cylinder, okay, with an inner radius of 4. So the radius is 4. And inner height of 8 inches. So the height of the cylinder is 8 inches. The other is a cube with inner height, width, and length each equal to 8 inches. So we have a cube. So let's draw the cube, which has length, width, and height all 8 inches. 8 inches. Length, width, and height is 8 inches. Now, the cylinder is filled with water, completely filled with water. Okay. And the cube is empty. If Raul pours the contents of the cylinder into the cube, so Raul pours the water from the cylinder into the cube, how deep will the water be in the cube? So water gets inside of the cube. So let's say it's getting partially filled. It's completely not filled. So we want to know the height of this water, means how deep is the water. So we know the length and the width stay same, 8 by 8, but the height of the water we don't know, it's unknown. So first let's find the volume of the water. So how much water we have. So the cylinder was filled up with water. So if we find the volume of the cylinder, we can find the volume of the water. So volume is equal to pi times radius power 2 times it by height. That's the volume of the cylinder formula. Now let's substitute the value. So pi, we know the radius of the cylinder is 4, pi times 4 square, and height is 8. So it's 4 square is 16 times 8 is 128, and we have pi here. So this is the volume of the water. Now water is inside of the cube. So let's find this volume of the water did not change. So the volume of the cube, we know that it's equal to length times width times the height. Now length and width of this cube stays same, 8 by 8. But the height of this cube, means the water, means mainly the height of the water is unknown. So we'll say h. But the volume of the water inside of this cube is 128 pi. So as you can see, we set up the formulas. The volume of the water, which is 128 pi, supposed to be is equal to, since it is inside of the cube, it should be length times width times the height. So length and width did not change. The height is the new height, which is unknown. So we assumed it's h. Now let's solve for h. So we have 128 pi is equal to 64 height, means h. Now divide both sides by 64, 64. We get h is equal to 2 pi, and that is the height of the cube, means the height of the water. How deep will the water be? That's 2 pi. Number 4. So we see a big cone here. It says water is pumped into a tank that is shaped like a right inverted cone, okay, shown above. So the cone has a diameter of 12 feet. So if the diameter of the cone is 12 feet, who can tell me the radius? The radius is 6 feet, half. Now, and the height of 4 feet. So we know the height of this is 4 feet, as they showed us. Now, what is the volume in cubic feet of the water in the tank when the height of the water is 2 feet? So we're going to put some water inside of the cone. So let's say water is up to here, all the water here. Now, this water has a height 2 feet. So the height of the water is 2 feet. As you can see that the water actually created a smaller version of cone here, baby cone, which has a height of 2 and the radius is unknown. So let's say the radius of this cone, baby cone, is x. Now they said, what is the volume in cubic feet of the water in the tank when the height of the water is 2 feet? As you can see, water created a baby cone, so we can use the volume of the cone formula to find the volume of the water. So what is the volume of the cone, guys? It's equal to 1/3 pi times the radius power 2 times it by height. Now we know that 1/3 pi is going to be there, and the radius of the cone we don't know. The baby cone here, we don't know the radius. How do we find it? As you can see, there are two right triangles. One is big right triangles with a base 6 and a height 4, like 6 by 4, and another baby triangle here, 2 by x. So we can set up a proportion. We can set up a proportion that the big triangle is 6 by 4, a 6 by 4 right triangle, and we have an x by 2 here, x by 2. So we can set up a proportion since the two triangles are similar. So we can cross multiply. So we get a 4x is equal to 12. Now divide both sides by 4. 4, we get x equal to 3. So that is the radius of the smaller baby cone. So radius is 3, so we can plug it in here. And the height is what? What is the height of the water, guys? 2. So now let's solve it. We have 1/3 pi. So 3 squared is 9. 9 times 2 is 18. So 18 times 1/3 is 6. So we have 6 pi. So the volume of the water means this baby cone is 6 pi. Number 3. It's a function question. It says assume s of x is equal to the sum of all positive even integers less than or equal to x. So take a look at it. Sum of all positive even integers less than or equal to x. So it has to be positive and even. So here we have s of 7. So let's find out all the numbers that are less than or equal to 7. So the numbers are 7, 6, 5, 4, 3, 2, 1, 0, -1, -2, and it keeps going. But we're not going to add all the numbers. It says the sum of all positive and even. So let's see, 7 is not even, so we cross it out. So if you're looking for positive and even, we can pick 6, 4, 2, and 0 is not even. I mean, 0 is not positive, it's definitely even. So you can cross it out. These numbers are not going to work. So, and of course not negative numbers. So we have only 6, 4, and 2. So s of 7 is the sum of 6 plus 4 plus 2, which is 12. And that is the answer. Number 2, rotation question, very important. It says if MN, the line MN, as you can see, is rotated 90-degree clockwise, 90-degree clockwise about the origin, what are the coordinates of n prime? So now the coordinates of n is 1, 0, and we'll have to rotate 90-degree about the origin clockwise. So what will be the new, we're going to name the new one n prime, new coordinates. Now the rule for 90-degree rotation is, 90-degree clockwise rotation rule is, if you have x comma y, a coordinate, so it will switch to y comma -x. It means if you have, let's say, 4 comma 6, it will become 6 comma, means the position of y, which is 6, will go to x, and the position of x, which is 4, will go to y, and it will become negative. If it is already negative, it will turn positive. Now let's try this one, our original question, which is n 1 comma 0, and if it rotates 90-degree clockwise, it becomes what? 0 comma -1. You are absolutely right. So 0 comma -1, that's C. Number 1, the most important one, repeating decimals, turning them into fractions. Now it says how is 0.6 bar times 0.2 bar written as a fraction in the simplest form. So let's see how this works, the repeating decimal. So let's say I have 0.68. How would you write just 0.68 in terms of fraction? It's 68 over 100, right? Now, if you have the bar on top, all you have to do is subtract 1 from the 100. So it becomes 68 over 99. That's it. It's that simple. So let's say you have 0.7 bar. So we know that just 0.7 is equal to 7 over 10. But since we have the bar, 0.7 bar will be 7 over 9. 1 less than the denominator 10. So now let's apply that. So 0.6 bar we have, it's 6 over what, guys? 10? No, it's 6 over 9. 1 less than what it's supposed to be. Now, times 0.2 bar means 2 over 9. Now, 6 over 9 can be simplified as 2/3. You can simplify it by 3. And this is 2/9. So you can multiply the numerators, which is 2 times 2, 4. And 3 times 9 is 27. So it's 4 over 27. It is that simple, guys. Just subtract 1 from the denominator. That's it.